Last week, a job posting for a prompt engineer listed requirements for distributed systems, API design, security engineering, and product management. That description covers the work of 5 separate roles. But while the job title is outdated, the technical requirements are accurate for the current market. This discipline is agent engineering, the practice of building AI systems that take autonomous actions in the real world. Transitioning an AI agent from a localized demo to a production environment requires solving a distributed software architecture problem. Chatbots that simply answer questions are being replaced by agents that execute state-changing tasks, such as processing financial refunds or querying live databases. Writing a prompt is like following a recipe. Building an agent is like managing the entire commercial kitchen, the timing, the safety protocols, and the integrated workflow. To build a reliable agent, you must integrate 7 specific engineering disciplines into your stack. If the underlying system lacks structural integrity, no amount of prompt adjustment will prevent the agent from failing in production. This is our baseline, an isolated large language model. If you ask it to trigger external tools without a control layer, the connections fail. An orchestrator ring provides a mandatory routing layer, allowing the LLM to communicate with tools in a controlled sequence. This layer handles traditional backend requirements, managing data flow and coordinating tasks between different specialized subagents or services. Without this orchestration layer, the agent is simply a collection of colliding microservices. Agents interact with the world through tools. To function, these tools require absolute precision in their input and output parameters. If a tool contract is vague, the LLM will use probabilistic imagination to fill in any missing information. On the left, a vague text instruction fails to communicate with a database. On the right, a strictly formatted JSON schema successfully validates the request. By enforcing a specific regex pattern for a user ID and marking it as required, you ensure the agent passes the exact data format needed for a transaction to succeed. Strict typing and exact contracts provide a structural guardrail that guides a probabilistic model toward a deterministic output. An LLM's pre-trained memory is static. For real-time problem solving, the agent needs a way to access current external facts. Retrieval augmented generation provides this context. A document block is sliced into uniform chunks and stored in a vector database. The system then identifies the data points nearest to the target query and pipes them back to the central orchestrator. To prevent irrelevant data from cluttering the context window, a second-pass re-ranking algorithm scores these results and promotes the highest signal information. The agent's reasoning capability is limited by the quality of this retrieval pipeline. If the context is irrelevant, the model's output will be confidently incorrect. In a production environment, external APIs fail and networks time out. These interruptions occur unpredictably. Without reliability engineering, an agent might get stuck in an infinite loop, relentlessly striking a failing service without ever pausing or timing out. To manage this, you must implement exponential backoff, a retry logic that increases the delay between attempts to avoid overloading the system.
This diagram shows a circuit breaker in action. When an API connection fails, the switch severs the red pathway and automatically routes the data stream through a secondary fallback path. Applying these traditional back-end resilience patterns creates the safety net necessary for an AI system to operate autonomously. An autonomous agent is an active attack surface. It is a point of entry that must be defended against manipulation. A prompt injection occurs when a user embeds malicious instructions, attempting to override the system to access secure data. To intercept these attacks, validation boundaries and output filters catch and dissolve the malicious logic before it can be executed. You must also establish hard permission boundaries. An agent should never have the authority to delete data or send emails without a human in the loop to approve the action. Without these security measures, a capable autonomous agent represents a significant corporate liability. You cannot verify a system's performance based on the subjective feeling that an output seems better. When an agent fails, you need to know exactly which tool was selected, what parameters were passed, and how the model reasoned. This level of detail requires full system tracing. We can now see the exact chronological path the query takes as it moves through every node in the architecture. This telemetry allows you to calculate deterministic metrics, the precise success rate, the latency per task, and the total cost per execution. You can only scale a non-deterministic system if it is anchored by constant objective measurement. Engineering is only half the battle.
the agent must also serve the expectations of the human end user. The core UX challenge is managing the inherent unpredictability of the model. An agent might succeed on Monday, but fumble the same task on Tuesday. To build trust, the user interface should surface the agent's internal confidence levels and provide a clear display of its reasoning steps. The system must offer graceful degradation, providing clear paths to escalate the task to a human operator when the agent reaches its logic limits. A perfectly architected backend will fail to gain traction if the interface does not correctly calibrate human expectations. This completed diagram represents the infrastructure required to move an agent from a demo environment to a live deployment. Your first step is to audit your tool schemas. Ensure that every contract has strict data typing and clear examples to eliminate model ambiguity. Second, stop modifying prompts when a failure occurs. Instead, use your telemetry pipeline to trace the failure backward and isolate the structural break in the system. In production, the root cause of an error is rarely the wording of an instruction. It is usually a breakdown in the system's architecture. While early AI roles focused primarily on refining text, the market has shifted toward a demand for systems architects who can manage the entire agent stack. The industry has moved past the experimental phase and now requires the same rigorous deployment disciplines used in traditional software engineering. Focus your efforts on building resilient software infrastructures rather than clever sentences. Prompt engineering initiated the current wave of AI development. Agent engineering provides the structural rigor required for these systems to operate reliably in production.
Thank you. Share and subscribe to Learn AI for more AI insights.